here is my graph. I'm going to make this just a little brighter. On the quiz, I will have it set up the same way where there's a spot for the left arm and the right arm of the graph. And also a spot for the vertical and horizontal asymptote. Vertical asymptotes are always in the form x equals, so that could be a note to write yourself. Always x equals. And horizontal asymptotes are always in the form y equals, because horizontal and vertical lines, that's how they're written. From looking at the graph, I could tell where my asymptotes were, or just from looking at the equation. So remember, you can do either way. So if you look at the graph and you see my graph doesn't touch or cross -4, you can tell there's an asymptote there. You can see it doesn't touch or cross 0, there's an asymptote there. Another way to look at it is -4 would make my denominator 0. Can we have that? No. So that's why -4 is our value for our vertical asymptote. And then remember, if the degree of the numerator is smaller than the denominator, our horizontal asymptote's at 0. So we can use what we know about the equation, or we can look at the graph. Or we can do a combo of both to kind of check ourselves, right? I think that's probably the best way. These were some of the points that I picked. Again, you could have picked different points. How do our graphs look, okay? Remember that graphs are kind of a heavy hitter in terms of the amount of points because there's a lot going on, right? Like there's asymptotes, there's 6 points, like there's a lot there. So make sure that you feel comfortable with that part. Questions before I move on to solving? Okay. So for solving, remember we look for what's in the denominator. What do you see in the denominator for number 3?
Y and a -4. Yeah, negative.
Yeah.
Y minus.
And do you see how they're together? They're like a package deal in the denominator.
Sure.
They need to stay a package deal. So when I go to multiply, I need to multiply by y minus 1 as a whole thing, as a whole entity. So that together here, it needs to stay together. Okay, so let's multiply. This -3 is going to get distributed. What's -3 times y?
3y.
-3y, right? Because of the
Oh,
negative,
yeah.
be careful there. -3 times -1. And if you don't know, use the calculator. -3 times -1. 3, positive 3, right? A negative times a negative is a positive, and then we know 1 times 3 is 3. Okay, on the other side, we have 5, and then the y minus 1 joins it, and it's all over y minus 1. So remember, when we multiply stuff, it always goes into the top. So what can happen here with my y minus 1s? They cancel out, which is exactly what we were hoping to happen, because now, look how easy that equation looks. What should I do next to keep solving? Subtract the 3. Good. So now I have -3y equals 2, because this canceled. Divide by what? -3. And we got a fraction, but that's okay. Our final answer would be -2/3. You could also give me a decimal and I'd be fine with that. So if you don't love fractions, if those aren't your favorite, you could also give me a decimal answer. So on my calculator, I would just do my, let me quit out of that. I would do my 2 divided by -3, and I'd get -0.6 repeating. That'd also be a fine answer. What do we put over the 6 when it repeats? A little line or a cap or whatever we'd like to call that. Yep. Okay. Let's go to the back. We've got some more solving problems. All right, number 4. What do you see in the denominator?
2 of the same.
Yeah, 2 of the same. So what should I multiply everything by? V minus 4 as a package, right? Not just the V and then a -4, but the whole package deal of V minus 4. Okay, I'm gonna freeze my smartboard. You try this one without me. I'm gonna do this one too, and we're gonna kind of meet back up and see how we did. So make sure you actually distribute the 3.
Oh my gosh, I don't know what I'm doing. Are we combining like terms at all?
We are.
Oh, okay, I didn't know.
This one ended up a lot trickier than the last one. I thought at least. There's a lot of things going on, and there's something weird with the answer too.
There is?
There is.
I,
Unless
Oh, I know. You can still, when you say it's weird, you can still get a nice number.
yes.
But what's weird,
Yes.
okay,
Okay.
okay.
Sorry, we're trying not to give spoilers right now. But it's like when you've seen the TV show, the other people haven't watched it yet, and you're
Okay,
like,
but
don't say
remember
the
part-
ending.
But you know the part
Negative
when,
5.
Yeah.
and then she says.
Right.
Wait, how'd you
But
get
don't
it?
tell them the ending. Right. Okay. Hold on. Let's talk through it together. This one is trickier. In retrospect, I would have done it together. Okay. Ready? 3 times the b, 3b. 3 times the -4, -12. Is that okay for starters? Okay. This one. Do you see how I put them together over the b minus 4? Equals. There's my b times the b minus 4 all over b minus 4. These cancel, so I just have my 4, and I just have my b. And there's my 3b minus 12. Are we okay with that part? Yes, no?
Yeah, yeah.
Okay. Yeah. When we add the -12 and the 4, we get -8. So that's how I got it here. Here's my 3b. Here's my -8. Here's my equals b. Subtract over the 3b, so all the b's are together. And divide. And I was like, yay, it's a nice number. Kind of like Miss Littleton said. We were both like, woo, nice number. But then, what did we realize? Well, if I go to plug in 4, what happens? 4 minus 4 is
0.
0. Can we have 0 in the denominator? No, so it's a no solution situation. So that one ended up being a wee bit trickier than I had. Just a wee bit. Okay. All right, look at number 5. 5's a little different because we don't have, I don't have anything like this one, by the way. Let's cross out 6. Goodbye, number 6. Nothing like you.
I thought
Bye,
you said
friends.
nothing likes you.
Oh, no, nothing like you on the quiz. Let's look at 5, though. What do you see in the denominator? What do you spy with your little eye? A 3 and a y. So I'm going to multiply by 3y to everything. So again, it's kind of like one of those Oprah moments. You get a 3y, everybody gets a 3y. Here we go. 3y times 2 is what? 6y. Equals. In the top, I'm gonna leave it not multiplied together. So I'm gonna do 2 times 3 times y all over 3. So see what I did? You see how here's my 2, my 3, and my y, and it's all over 3. Okay, so I'm going to do that just like that for now. Minus, I'm going to do the same thing here. 7 times 3 times y all over y. So I'm not even going to multiply stuff yet. Because do you see how something's going to cancel?
Yeah.
Okay. So all I did is I just smushed them all together in the numerator. Smushed them all together in the numerator. What can cancel in this fraction? The 3's. Bye, 3's. So now I have 6y equals, do you see how I just have a 2 and a y left? Okay, so 6y equals 2y minus, question? Are you good? Just sighing. Because it's Monday and it's math? Okay, that's fair. So the 3's canceled, so I just have my 2 and my y. Over in this fraction, what cancels?
The y.
The y's cancel. So I have negative 7 times 3, which is negative 21. All right. Now, let's move our y's together. How can I move my 2y over to be with its other y friends? Yeah, let's minus it. So subtract over your 2y. 4y equals negative 21. Now what? Divide by 4. Not the y, just the 4. And then this is going to be our final answer. So again, it's a fraction. Could we also write a decimal if we like decimals better? We could. Yeah, we could write a decimal if we'd rather. Now, do you see how the only thing that would make the denominator 0 is if y were 0?
Yeah.
Yeah, that's not what we got, so we're good. We got a weird answer, but that's okay. All right, those are kind of tricky. Let's move on to the other part. I think we were doing pretty well with these. Zeros of the oh, go ahead.
I don't get how you got trans.
Where did I lose you? Was this okay?
Yeah.
Okay, so I subtracted the 2y over. So now I have 4y's equal, there's my negative 21. And then I divided by 4. So ugly fraction. Or, like I said, if you'd rather do a decimal, I'm fine with that. Yep, there's a lot going on here. All right, last little bit. These were actually quicker, believe it or not. Zeros come from the numerator only. So I'm going to write myself a note. Numerator. All right. I don't know when that equals 0. Do you see how there's a lot going on and it's squared?
Yeah.
These were the times when we factored. So give me 2 sets of parentheses. Equal to 0. So numerator equals 0 are my zeros. This is the difference of squares. How do I factor it?
X.
Yep. X plus and minus. And then what should go in that second spot? 10 and 10, that's right. Because we're taking the square root of 100. Okay, so we need to find what would make the numerator 0. So look inside your first set of parentheses. What could I plug in for x that would zero this whole thing out? Negative 10. What could I plug in for x for this one? 10. So those are my two solutions. One solution is negative 10. One solution is positive 10. Do you remember where vertical asymptotes come from? The denominator. So this is when the denominator equals 0. So see these two little notes that I've written myself right here? Those are pretty important, and I would have them on your paper too. So look at your denominator. We've got 4x plus 5. And the question is, when does that equal 0? I don't know. Let's find out. How would you solve this for x? Minus the 5. So I get 4x equals negative 5. On what?
Divide the 4.
Divide the 4. So I get x equals -5 over 4. So that would be my final answer. Could I give a decimal if I felt like it? You could. Alright, so this one, I would write myself a note to say, look at your bonus notes. Look at bonus notes. Because, do you remember we had those 3 rules? The first rule said, if the degree of the numerator is bigger, then there's no horizontal asymptote. So let's check and see if that's true. What's the degree of my numerator?
1.
1. What's the degree of my denominator? 3. Is the degree of my numerator bigger?
No.
Is 1 bigger than 3?
No.
No. Okay, then the next rule said if the degree of the denominator is bigger, then it's at 0. Is that the situation I'm living in?
Yes.
Yes. So that's going to be y equals 0 for my horizontal asymptote. So look at bonus notes for the list of 3 rules. All right, number 10, last but not least, we're almost there. This one, we are going to look for the match. That's where the point of discontinuity, or we can also call it a hole, that's where that's going to live. So what set of parentheses is a match? X minus 8 is the match. And then we think, what would make it 0? Positive 8. And that's going to be our final answer. So that should be kind of your brain thought process. Your brain should tell you for the whole, look for the match. There it is. What would make it 0? A positive 8. Questions? We're good? Okay. So we'll review